Hi everyone! In this demonstration, we showcase the use of large language models for intent translation in the Eurecom 5G facility. This latter empowers vertical users to manage and coordinate network services efficiently. In addition, it allows them to oversee the lifecycle management of these network service applications at the edge network. Within this platform, network services are created using the network service descriptors through the graphical user interface. This is implemented using JSON structure in the web portal, and it is sent to the NFVO network function virtualization orchestrator, which is responsible for onboarding and instantiating these services in the network function virtualization infrastructure NFVI. The structure of the network service descriptor is shown in this figure. As you can see, the NSD contains metadata, where we define, for instance, the name of the network service and the region of deployment, which means in which edge cluster the MEC applications will be deployed. In addition, it contains a list of AppDs. Each AppD describes or defines a MEC application. For example, AppD metadata contains the name of the application, virtual compute descriptor and virtual storage descriptors define the set of resources needed by this application. Software image descriptor defines the software images and the orientation of the exposed ports. This latter can be either towards the container network for internal communication between AppDs of the same network service, mobile network if the application running inside the container needs to be exposed to mobile network. This is for cases where user equipment will use the application deployed at the edge via traffic redirection rather than going to the internet. And internet for container applications to expose its graphical user interface towards the internet. The NSD also have other fields related to application DNS and traffic rules. Through the portal, there are two options available to create the NSD, either by uploading the JSON file directly or filling out the NSD form, and then the NSD JSON file would be generated by the web portal. However, these NSD creation processes can be rather complex, especially for vertical users unfamiliar with the NSD file structure. Currently, verticals are required to have knowledge about the NSD structure to deploy these network services successfully. Therefore, enhancing the NSD creation process becomes an evident choice. Vertical users should simply explain their network service needs in plain language or intents, and the NSD file will be generated automatically using large language models. In intent-based networking systems, this process is called intent translation. The vertical user can log into this platform and create a network service from plain language. In this example, the intent is to create a network service that contains two applications, GPS northbound and Mongo database. The northbound will be exposed to internet using port 80 and to mobile network on 9863, and the database will be exposed to container network. Both software images should be pulled from the internal image repository. Now, the vertical requests the LLM to generate the NSD. Let's see what's happening in the background at this step. The vertical portal sends a post request to the translation agent. This latter extracts some few short examples from the knowledge base and requests the LLM to generate the NSD. Once the NSD is generated, it undergoes a validation process using the validation agent. This latter ensures the correctness of the NSD through a three-step process: syntax validation, semantic validation, and correlation validation. It will request the LLM to correct the NSD if any errors are detected. Then the correct NSD is shown to the user. If human feedback is activated, the vertical user can correct the NSD and store it in the knowledge base with the query. This will enhance its performance for future similar cases. The NSD is generated and meets the requirement of the user's query. As you can see, the GPS northbound was used and the image was pulled from the internal repository and is exposed to internet using port 80 and mobile network using port 9863. And the second application is the database which is pulled from the internal repository and exposed to container network. The vertical sends the feedback here, and this example, which means the query and the NSD, was added to the knowledge base. So now the user can create the slice directly using the generated NSD. The slice is created and is running, and as you can see, we have the two applications, the northbound and the database. We can also access the northbound via this graphical user interface. Thank you for your attention.